Growth and construction have a profound impact on our environment, economy, and productivity. ROADBOND EN1 is a well-established, proven soil stabilizer that addresses the important challenges of our time, which are to reduce the consumption of water and natural resources during construction. Also, it is vital to lessen the dependence on non-sustainable sources of energy, lower greenhouse gas emissions, and to minimize the carbon footprint of projects. ROADBOND EN1 contributes to a sustainable environment when replacing or reducing lime and Portland cement stabilization. It may qualify for LEED credit under Innovation in Design because it significantly reduces the environmental impact when compared to conventional calcined soil stabilizers. For example, ROADBOND EN1 reduces carbon emissions and saves fuel because it is concentrated and can be transported to the job site in a pickup truck. Because it is concentrated, one 5-gallon pail of ROADBOND EN1 will replace 12 tons of lime. That is over 1 1/3 transport loads of lime slurry that is not transported to the job site, and the corresponding relief in traffic congestion, noise, and diesel exhaust fumes. To understand how dramatically ROADBOND EN1 will reduce the environmental impact of construction, consider a typical 54,000 square yard project stabilized 6 inches deep. This project would require 720 tons of lime slaked with 405,000 gallons of water delivered in more than 80 tanker trucks. Compare this to 300 gallons of concentrated ROADBOND EN1 and only 60,000 gallons of water, which will be mixed at the job site. This represents a water savings of 675% and a fuel savings to deliver the lime to the job site of at least 675%. Furthermore, ROADBOND EN1 will significantly lower energy consumption compared to conventional stabilization. For instance, lime is produced by mining and crushing limestone and then burning that limestone in kilns during a process called calcination. The Department of Energy reports that more than 8 tons of limestone must be quarried and processed in order to produce 1 ton of lime. After the material is crushed and screened several times, it is washed, processed, and delivered to the kiln. The calcination of limestone requires temperatures in excess of 1,400 degrees Fahrenheit over an extended period of time. While this requires a vast amount of energy, the quantity varies according to the impurities in the limestone and the type and efficiency of the kiln. However, the Intergovernmental Panel on Climate Change has determined that the theoretical sum of energy consumed for the production of lime in the U.S. and Canada is 7.2 gigajoules per ton of lime produced. That is equivalent to 2,000 kilowatt-hours of electricity consumed per ton of lime produced. For reference, in 2007, the Energy Information Administration calculated that the average monthly residential electricity consumption per home was 936 kilowatt-hours. Therefore, replacing 12 tons of lime with 5 gallons of ROADBOND EN1 is equivalent to taking 16 average homes off the power grid for a month. So, on the example 54,000 square yard project, replacing 720 tons of lime with 300 gallons of ROADBOND EN1 could offset the energy consumed by 960 average homes in a month. ROADBOND EN1 also contributes to a sustainable environment by significantly reducing greenhouse gas emissions. Carbon dioxide, CO2, is one of the greenhouse gases that contribute to global warming and is subject to the Kyoto Protocol. CO2 emission is a direct result of limestone calcination, and the amount of CO2 produced is a function of the calcium carbonate, magnesium carbonate, and impurities in the limestone feedstock. However, the Intergovernmental Panel on Climate Change has estimated that CO2 emission produced by calcination is over 1,700 pounds for every ton of lime produced. Fuel consumption during mining and processing will add an additional 900 pounds of CO2 per ton of lime produced. This totals more than 1.3 tons of CO2 emitted into the environment for every ton of lime used on the project. Replacing 12 tons of lime with 5 gallons of ROADBOND EN1 will reduce CO2 by 15.6 tons. Again, referring to the 54,000 square yard project, replacing 720 tons of lime with 300 gallons of ROADBOND EN1 will reduce CO2 by 900 136 tons. For comparison, according to the EPA, the CO2 emission of the average automobile based on 12,500 miles per year is 6.8 tons. The use of ROADBOND EN1 on the example project will offset the CO2 produced by 1,650 vehicles in a month. That offsets CO2 produced by driving over 1.7 million miles. Other CO2 research funded by the EPA has shown that the reforestation of land will sequester more than 2 tons of CO2 per acre per year. This indicates that a single 54,000 square yard project with ROADBOND EN1 instead of lime could replace the yearly carbon sequester of over 400 acres of reforested land. What is more, the EPA has also identified the lime manufacturing industry as a major source of hazardous air pollutants that include hydrogen chloride, arsenic, cadmium, chromium, lead, and mercury. The use of ROADBOND EN1 to replace or reduce conventional stabilization is a comprehensive strategy that demonstrates quantifiable environmental benefits. It promotes a sustainable environment in the areas that matter most: energy savings, reduced water usage, reduced CO2 emission, and stewardship of resources. It has withstood the test of time, changed the status quo, and redefined stabilization. For a greener today and a cleaner tomorrow, specify ROADBOND EN1 patented soil stabilizer on your next project.